a small change in hen survival rate could mean a big impact on the population growth rate.
This is the closest thing and the most convincing thing to a unifying theory of turkey decline that I feel like I've seen.
Welcome to Wild Turkey Science, a podcast made possible by Turkeys for Tomorrow. I'm Dr. Marcus Lashley, Professor of Wildlife Ecology at the University of Florida.
And I'm Dr. Will Gulsby, Professor of Wildlife Ecology and Management at Auburn University. We're both lifelong hunters and devoted scientists who are passionate about hunting, managing, and researching wild turkeys.
In this podcast, we'll explore turkey research, speak to the experts in the field, and address the difficult questions related to wild turkey ecology and management.
Our goal
is to serve as your connection to wild turkey science. Sucked it down fast.
Don't leave that audio in.
I love how you rushed to...
I tried to get that sip of water right before the mic went hot.
Oh, that's funny.
I knew I was going to have to be hydrated for this one.
Yep, this one's going to be strong, I think.
How long have we been teasing this? At least since we started, since you first had the concept of this analysis, I believe.
Yeah, and
and we started seeing some of those preliminary results.
I was trying to figure out when that was. So we're currently in September of 2025 when we're recording. I don't know when this will go live, probably in October of 2025. When I went back, I'm pretty sure that I started gathering data on this in May of 2024.
Yeah, that makes sense.
And I'm pretty sure that you're a co-author on this, and so is Coulter Chitwood and Anna Muller, and a couple of other folks from my lab, Alex Potash and
Mark Turner,
Kelly O'Neill and Mark Turner. Who else is on there? That's everybody.
Yep.
So a bunch of people have worked on this, and I'm the lead author on it, and it's going to be published in the symposium, the National Wild Turkey Symposium, the 13th symposium in the Wild.
You got that lead authorship because you did all the math for it, right?
Oh, yeah. No. I can go on and say Anna Muller and Alex Potash, I would say, carried the majority of the analytical weight. Yeah. And then Coulter would be a near third right behind them.
Yeah.
And then the rest of us didn't do any of the math.
Yeah. The rest of us did not.
So I did lead the writing and the idea, and particularly the idea spawned from me and you talking with Coulter, I'm pretty sure.
Mm-hmm.
And it kind of, we brought in, which we'll talk about, some of their Coulter and Anna's skills and expertise to try to make this well-rounded.
Yeah, the idea came after, I think specifically Coulter found such a abysmally low hen survival rate on one of his study sites.
Yeah, it was sub 40%, I think, wasn't it?
Well,
so,
yeah. Didn't they have 0% one year? Or I'm thinking 0% nest success, maybe.
No, I think it was poults.
Okay.
But yeah, they did have. Yeah, that's where it started. But then it was like, we all are colleagues and friends, and we try to put together our heads and expertise sometimes to deal with stuff like this. And to me, the light bulb went off when we're talking about turkey decline. And then I have someone on like Coulter or Anna that tell me that by far the most important vital rate in populations to dictate whether they're growing or declining is annual hen survival. And then they tell me their hen survival was worse than abysmal. And then I heard about Tennessee's, and I was like, wait a minute. I started, that's what kind of started me down that path. And then it wasn't that long after where I reached back out to you guys and I was like, hey guys, look at this, where I, found like 10 or 15 estimates. You remember that? And I sent you a figure. So then it was like, well, we don't need to stop there. Let's get all of them.
Mm-hmm.
We're not trying to discard any data here. And when I mean all of them, I meant we scoured the literature and found I'm pretty confident it's every one.
Yeah.
Every published, whether it was peer reviewed or not, we've got theses and dissertations and government reports and everything, but every annual hen survival estimate that we could find is in the paper.
Mm-hmm.
So to me, that's a really important contribution to our knowledge, is we're trying to take all of our studies that we've ever done on something and then apply a meta-analysis approach. Folks have heard us say stuff about meta-analyses, but basically we're analyzing the patterns across all the studies.
Yeah.
And there's a formal approach. And again, I don't do math good, but I do understand, I think, how this works. Basically, we're assigning relative weight and relativizing results across studies to try to get at patterns, in this case, over time. We were really interested to look at how has hen survival changed over time?
Yeah.
Which the answer to that may be it didn't.
Yeah.
Right? That's kind of our null hypothesis. So that's where we started.
Yeah, and this paper has been through the peer review process. It's not published yet, but it has been accepted.
Yeah, we do have it available in preprint currently, and it'll be out in the symposium. It has been accepted.
Yeah.
So we've been waiting on this one and teasing about it, and we didn't want to get out in front of it before it's gone through peer review, because I think it's particularly important.
I mean, this is the closest thing and the most convincing thing to a unifying theory of turkey decline that I feel like I've seen.
I agree. So that's not to say there aren't weaknesses with the approach, which we'll discuss some.
It doesn't have all the answers, but
right. It's definitely a powerful approach.
I feel like it gets us closer than we ever have been.
Yeah. So let's don't tease folks any further. So just as a recap for everybody, when we are trying to understand how a population is performing, we will collect vital rates. And, we can link Coulter's description of this from one of those early episodes where he talked about the Landy et al. Paper. They went through the literature and got all of the vital rates, and they projected populations from what all of our estimates were on wild turkeys. And I think they restricted it to Easterns.
Yeah. And just to be clear, vital rates are rates that are vital to the functioning of that population. So in the case of turkeys, things like survival at different age classes, nest success, brood survival, so on and so forth.
Yeah, everything that affects where that population is going to go is essentially included in that. So nesting success, but also nest initiation rate, and that being split between age classes, like you said. And so they had already done this work, and we've already covered it here, and they projected, based on all the published vital rates, that turkeys should have been declining at about 9% per year.
Mm-hmm.
So that, is definitely noteworthy. But when they did that analysis, they looked at two aspects of the analysis, and I'm probably going to get this wrong, but there's a sensitivity analysis that tells you how important a variable is, like how much weight is it carrying in terms of how it affects the population's growth rate.
Yeah. How sensitive is the population to this parameter?
Right. And then there's a different one, a different part of that analysis that tells you how much it varies.
Mm-hmm. Elasticity.
Elasticity is the term, yes. Mm-hmm. So you have how sensitive is the, or how much weight is it carrying versus how much can it vary, and they're kind of different. And again, I'm paraphrasing Coulter and probably not doing it well, so you can go back and listen to him explain this, but you can kind of interpret that hen survival is the most important in terms of carrying the most weight, but it doesn't usually vary in the literature very much.
Yeah, it's just like stable.
Yeah. It's very stable in the long term in a population, and you get much more variation out of reproduction from nesting success,
which is really up and down from one year to another.
Yes. So it and to draw some inference from that, basically we have focused on reproduction and trying to improve that through management because it is elastic.
Yeah.
It will respond to management.
Yeah.
So based on that, we should expect that hen survival has just been stable over the long term.
And the other thing too, Marcus, is important to point out here, I think, as well as we do have some evidence suggesting that those vital rates have been declining, right? The nest success and the brood survival.
Yeah, really good study on this that was comprehensive for the Southeast was Byrne et al. 2015, which I think we have covered. Even didn't we cover it with Mike Byrne?
Yeah.
And they essentially showed that poult per hen numbers had steadily declined. And in their case, they looked at a shorter time frame over a smaller geographic region, but over the time frame they looked at in the space, in the place they looked, the hen survival had generally inclined. Mm-hmm. That's what it looked like based on their data. Mm-hmm. So, and that's where they ended up on that density dependence idea that there seems to be something limiting reproduction, but it's not limiting the other vital rates, and it was operating in a density dependent manner. So we're throwing a lot at you, I know. Yeah. But we've got episodes going into each aspect of this in detail if you're so inclined to go listen. But I feel like it's important for the context because it's kind of setting up the frame of mind that we were in when we went down this path.
Yes.
So I thought, okay, hen survival is supposed to be stable over time, but even a small fluctuation in that value could have a big consequence on the population. So if it has declined, that would be important to know.
Yeah, and for, all the hunters that are listening, most of our audience, including us, they're going to be familiar with the deer harvest example, right? Where we know we can lower deer populations by increasing female mortality or, conversely decreasing survival. Kind of the same concept that adult female survival is so important to population growth rates because they're the reproduction engine of the population.
Mm-hmm. Yeah, we manage the female segment to regulate how many are in the population or what the trajectory of the population is, wherever the males are expendable.
Yeah.
Whether you're in the deer example or whatever.
Right.
They're not the ones governing what the population trajectory is. So that's why I got so interested in it, because Coulter and them, they can't hardly get a hen to live a year, it feels like over there. And then I knew the Tennessee data set, which we've also covered in great detail multiple times with Craig. I knew their hen survival was not so good. And then I thought, well, what about all the other hen survival? And I started looking, and it's like, wow, some of these recent ones are really low compared to some of these back in the day. And that's where we got. So in this study, we went and scoured the literature, and we ended up with 46 publications, I believe, that had 51 independent estimates from a population. Mm-hmm. So that's a lot of studies. It's not even close to how many nesting success studies we have or some of these other things that we've studied more. But it's a fair number of studies, and it includes all the subspecies except for Osceola. Mm-hmm. There's never been one on Osceolas.
Right.
In fact, if you're watching this on YouTube, I'm showing a map right now of where all the studies were, and there are a bunch of states that never have had one before.
Right.
We are working on that in Florida. but there's several other states where we need to estimate that, especially given we've just talked about how important hen survival is to the population trajectory. Sure. We need that data.
Yeah.
And that's a gap from my perspective that, we can easily identify.
Well, and one of the reasons those gaps probably exist is in the past, adult hen survival has never really been pegged as being a problem.
That's right. Because it
was high and stable.
It's not elastic.
Yeah.
It doesn't fluctuate much.
Right.
And, to be honest, when we go back and look in the data in the 80s, the hen survival, when all those populations were being restored, the hen survival was through the roof in those populations.
Yeah.
And, even more recently, when Byrne and them looked at it, that didn't look like a problem then. And that was, their data set went up through like 2010 or 12, although it was restricted to just the Southeast.
Yeah.
So, that's right. We've known that it's important to the population. That's been noted numerous times, and it's widely known across a lot of species as well. But we've never had a reason to think that was a problem with turkeys.
Right.
So we've got all the subspecies included except for Osceola. And I think the most of the estimates are in the Southeast is best represented. Mm-hmm. No, the Midwest is best represented, but the Eastern subspecies is by far the most represented. So we have a few more studies in the Midwest than in the Southeast, but fairly equal coverage across much of the Eastern United States, although there's a few states that don't have an estimate.
Yeah, I mean, I'm looking at these dots on the map for our audio-only listeners, and we've got, all the way covered from down in South Louisiana and South Texas up into the Great Lakes region, over to New England, and then over to Oregon. So,
yeah, and the one in Oregon is the eastern population, I'm pretty sure, that got released over there.
Yeah.
And they're color coded also because some of the effects that we might observe in a data set like this are regional.
Yeah.
And we were trying to capture that, but if you did it by subspecies, it's kind of weird the way they're distributed because of like the example in Oregon.
How much we've moved them around.
Yeah, we've moved them around a lot. And we were we know that like weather, for example, is a really important thing for hen survival in the north. When you have a cold winter, survival's really low. Well, that's not a big deal in South Alabama.
And then rainfall is a huge deal in, Texas and New Mexico, for example.
Yeah. So we're trying to figure out. So we actually did the modeling based on where we're at in the U.S. and based on subspecies. Frankly, it didn't matter how we cut the data up. We found the same thing every time we looked at it. It didn't matter, which gives us a lot of confidence that that's a real pattern. But you're looking at what the end result was in the paper, but we included the other, like grouping it by subspecies, in the supplementary files as well. So we didn't hide that from anybody, but we did try it different ways to see what made sense, and it turned out it didn't matter. So one thing I think when we had Lehman on from South Dakota, he may have talked about this. I don't recall now. When we had him and was it Chris Rhoda on here? I think they may have talked about this, and this was another thing that kind of made me really want to go down this path with hen survival, was because they have done work up there and identified that was a problem.
Yeah.
In South Dakota.
Yeah.
And they talked about that on the air with us.
Yeah.
And one of their papers, they noted that a 0.68, so in other words, 68% of hens surviving on an annual basis was that threshold where they needed to achieve that for the population to be stable or grow in their studies.
Yeah.
So that's really interesting. When we look at the estimates across all of our populations, the first estimates, which I also want to add, we only used hen survival estimates that were based on radio tagging. So we could derive these from other ways like band recovery, and we did not use that because it is less certain.
Mm-hmm.
So we wanted to have a fairly high certainty. And let's see.
I feel like we need a drum roll for this.
Of the 51 estimates, 23 of them were after 2004, and the rest were before 2004.
Okay.
Or up till 2004. The ones all the way up to 2004, on average, were at that 0.68 or higher.
Okay.
More than half of our estimates.
Yeah.
And most of those are above or at 0.68, that threshold that Lehman and others identified.
And the average was 0.62 for that period of 78 to 2004.
0.62.
Yep.
Yep. But post 2004, so 2005 up till 2023, we have 23 estimates.
Mm-hmm.
And 15 of those 23 are lower than that 0.6. So most of them are lower than our threshold that Lehman and others identified was needed for a good sustainable population.
Mm-hmm.
So that's alarming. And that, that's what, when we look at this figure that we're putting up now, you can see in the dark gray, when we just model all of the data points together, you can see that in the early part of that graph, in the early 80s in particular, the estimates were pretty high.
Mm-hmm.
That sort of planes off from the early 90s through the, that 2004 range. So we have fairly stable over that time frame.
Yeah.
And then in the early 2000s, we see that decline. And we did do a mathematical thing to figure out that was at 2004 when that started.
So that was the biggest, holy crap moment for me when we started going through this analysis, was that the inflection point was right there at 2004, around that time period where, especially in a lot of states that restocked early, that's about the time they had their max harvest, and then it started to decline.
Yeah, and everybody started getting more and more alarmed all the way up through the 2010s.
Right.
Where, we started really picking up, there's a problem.
And that's when you started seeing a lot of research projects being initiated in response to that problem.
Yeah. So you can see on the same graph, when you look at each region, that same pattern is evident. I think it's most obvious in the Southeast.
Yeah, the pattern in the Southeast is so tight.
Yeah.
Around that curve. I mean, it's high.
Yeah.
And then you get to 2004, and then it just drops.
And then, when Byrne et al., if you look at the Southeast, because that's what the region they were working in, if you look at the Southeast, minus the one that was way back in the day, I think that was Speak et al. In Alabama, that was in 78. If you don't include that one, which they may not have. I don't think they did. I think they looked at the ones in the 80s up through the 2000s.
Yeah.
Over that part of that study set,
it
does look like it's, if anything, we'd say it's slightly inclining, which is what they said. There wasn't a strong pattern, but it seems to be increasing, if anything. And then after that, we've had a number of studies come out, and that's where the bottom fell out for some reason. So you're exactly right. When I saw that, I was like, man, that coincides really well with what we have observed in populations across a lot of places.
Yeah.
So very interesting, to say the least. So I think this is a good time to talk about some of the issues here.
Mm-hmm.
These are study areas, that are plopped around in states, and for most states, we don't have but a couple, if we have any. Some of them we don't even have any. So we might be, for example, in Alabama, we might have one or two study areas, like a WMA or somewhere in the state, that is the entire representation for that state.
Yeah.
in one time point, right?
Yeah.
And that's obviously not necessarily representative of what's going on at the state level.
Right.
Right. And I think anybody would agree with that.
Yeah. I mean, that's a major caveat.
One of the problems with this kind of approach is we've got 51 estimates that's representing 1978 through 2023 across the whole, the whole thing. So we were concerned about that, obviously, because we should be as researchers, to make sure that the pattern in the published literature actually matches the pattern in nature.
Yeah.
So we did several things to try to make sure that this was a realistic pattern. One of the things that I think is fairly compelling is we went to states that had multiple estimates over time. Yeah. And that was Alabama, Arizona, Mississippi, Ontario.
Mm-hmm.
That's Canada, not Ontario, Alabama.
Glad you clarified that.
South Dakota, Texas, and Wisconsin. So those are all the ones that there was more than one estimate over, with at least a decade between the estimates.
Right.
And I think all of them, except for Wisconsin, the earlier data points had a higher hen survival than the later ones.
Yeah. Yeah. Like Alabama's went from, was that about 0.77, like 77% of hens.
Yeah, I think it was 0.78.
Survived a year in back late 70s. And then you go up to 2020 and it's less than half.
Yeah. Pretty stark.
Very.
Mississippi, something like that too.
Yeah.
Where the more recent values are substantially lower than the ones back in the 90s, early 90s. Texas, South Dakota, all of them showed that same thing. So that gave us more confidence.
Right.
With the exception of Wisconsin. In every case, the early estimates in a given state are low or higher than the estimates more recently. So it gives us more confidence that this is a real pattern. And to take that a step further, there was one site, like one study area, where we had multiple estimates from the same study area over the long term, and that was Lehman et al.
Yep.
And I think the more recent one was from Tile et al. But Lehman was still involved with it.
Right.
And that was the one instance where the same population had multiple data points, and that one substantially declined.
Yeah.
Over that 20-year period. So no matter how you look at it, no matter which region we're in, even when we drill in and look at the state level or even on the study area, we don't have any deviation from that.
Except Wisconsin, apparently.
Except for Wisconsin. And that's because of cheese.
Yes, I was going to make a cheese reference. I couldn't figure out if I wanted to go with cheese or beer, but.
Well, their cheese has been stable. So that gave us a lot more confidence in it. And, we still need to go out and do more work on this. And I mean, clearly some states, we don't even have estimates in it. We have data in Florida now across many sites that hasn't been published yet and isn't included here because it's not published yet. But we will have that for Osceolas across their entire range here soon, which is pretty cool.
Yeah.
But, to me, that presents a pretty powerful hypothesis for why, and it coincides really well with when and where we saw declines.
Right. So are you ready to talk about how that affects what the population trajectory now? Because I feel like that's what people are going to be really interested in.
Did you say the average? You said the average for 78 through 2004, right? So that was 0.62.
Yeah. I think it's worth reiterating before we get into this.
Yeah, so on average, over that time period across all studies and subspecies, which I'll also add, the meta-analysis also has a real strength. So if people are trying to look at these graphs and squint to see the patterns, some of it you can't see because it's taken into account things that you can't see.
Yeah.
For example, what is the sample size of the study? That is weighted into the model.
Yeah.
So really powerful approach, and it's applied all across ecology all the time. And usually we don't have this good of data, so that's nice for turkeys.
Yeah.
But across all those studies, on average, the hen survival from 78 through 2004 was 0.624.
Yeah.
So 62% survival rate.
So on average, if you start out with a population of 100 hens, 62 will be alive next year.
Yeah. If you go and look at from 2005 to 2023, that average drops down to 56%.
Yeah.
0.56. So a lot of people are probably out there is like, well, that's not that much.
Yeah.
But remember, this is the most important vital rate, and Anna Muller has said this multiple times, and now it's etched into my brain, where a small change in hen survival rate could mean a big impact on the population growth rate.
Well, it compounds.
Yeah.
Right. So in 1 year, you're carrying, only 6 more hens from that population of 100. But those 6 hens presumably each, lay a clutch of 10 eggs, hopefully produce some poults. And then it's like each year you've got more of those hens that you're carrying over, and it just compounds on it. It's like compounding interest. I mean, people understand that.
Yeah, and the hen is relatively long-lived if she doesn't die every
year. Or she should be.
Yeah, she should be long-lived, and if you're carrying a lot of them, they could produce clutches of eggs year after year for many years.
Right.
So when you lose a hen, you're losing all of that reproductive output over her lifetime and thereafter.
That's right.
It's weird to say over a lifetime, but over her potential lifetime.
Yeah.
Right, because she obviously doesn't have a lifetime after she's dead. But so 6.5% decline on average. One thing that I will know is part of this approach we're capturing variation, and there's quite a bit more variation on that number in the later period.
Mm-hmm.
So we see a lot more variation from year to year, which is also an indicator there. Remember, hen survival is supposed to be stable. So it's a little bit of a red flag that there's more variability in that metric over that time frame. So that's important, though, because when you look at that variability, the lower is lower and the higher is higher, if that makes sense, because there's more variability around it. And what we did is this crazy modeling approach that Anna knows how to do and nobody else on the planet does. That's not true. Nobody else in this room knows how to do
it. Nor in this one.
So anyway, what we wanted to do is put the change in hen survival into context. Okay, so think about it this way. We know what low survival is, hen survival, based on this in each time period. We know what average is. We just told you the average. We know what high is. And we also know, because of the Lundy effort, where they characterized all of the vital rates in that study, we know what we should expect a low, medium, and high survival of like nests, or let's just say reproductive effort, the other part of this equation. We know what low, medium, and high is. So we wanted to do a modeling approach where we see, okay, under our current hen survival versus what historical hen survival was, what is the impact of that to our population given a low, medium, or high reproductive success?
Yeah.
Right?
That's an important question to ask, especially because so much of our management efforts have been focused on reproduction, increasing nest success and brood survival.
Yeah.
So it's important to figure out, how to also know, like, is that what we should really be focusing on?
Mm-hmm. So, and also for me, I look at the 6%, difference in mean, and I was like, well, does that even matter?
Yeah.
And this is actually measuring, does it matter?
Yeah. Turns out it does.
It matters a lot. So essentially, when we plugged it in, we determined that when survival in the early period was insufficient for a stable or growing population. And what I mean by that, we have to have a good reproductive year for the population to be growing, even under that. You remember it was 0.62.
Yeah.
So on the average, we need a relatively good reproduction. So in fact, it's the 81st percentile. So we need to be up in that upper fifth of years for the population to grow in that year.
Mm-hmm.
So if you think about it that way, we need a boom in reproduction every 5 years to stay stable.
Mm-hmm.
I'm trying to think of a way to make this make sense to people that don't understand this, because I'm assuming, like me, other people might not understand all this math.
So I have been racking my brain over how can we deliver this information related particularly to figure 5 so that it makes a lot of sense.
Yeah, it's kind of hard to get your head around. It's not super straightforward.
Yeah. So, when we established, based on this analysis, based on what has been published, that hen survival declined, and that's been very consistent across the range turkeys, and I think that's important for us to think about. But we wanted to put that into context and say, well, how much does that change matter?
Right.
And this is some of that fuzzy Anna math, where she's done some kind of math, and it's hard for us folks
by
like
fuzzy,
me to understand it.
By fuzzy, you mean fuzzy to us, not that it's.
No, she knows exactly what's happening.
Yeah.
But we're like the little kids standing outside the black box, and she's in there pulling strings, making stuff happen, making this thing robust. I mean, it's robust.
Yeah.
I have absolutely 100% faith that the math is accurate.
Well, and also,
I didn't do the math.
That's why I didn't want to talk about it until it had been accepted for publication, because it's gone through that process and had other quantitative ecologists review it to make sure that the math is right.
Yeah, and it's so important because, like you have said before, this is a sort of like a unified hypothesis that's very consistent that would explain trends we've seen in populations.
Right.
And we want to get that right, obviously. So, when we're looking at the probability of a population growing, right, people might kind of squint their eyes like, what are you talking about, probability? Well, the problem that we have in these populations is there's some uncertainty. Like, you measure nesting success on 100 individuals and you get that the nesting success is 60%. Well, the reality is that could be somewhere between 48 and 72%, right?
Yeah.
It's not actually 60% most likely.
Depending
it's
on
probably
the individual and the year and all sorts of things.
Right. So then we can multiply that times 100 studies.
Mm-hmm.
And you can see where now we're kind of in this, this ground where we know what the population is doing on average, but there's all this variation around all these vital rates. So we did this matrix modeling approach where essentially what they did is take, the range in nesting success, the range in hen survival, the range in all these different vital rates that are going into the model to see is the population growing or not. We randomly let each of those vary and ran the model 10,000 times over.
That has actually been studied. So
so we know nesting success is between 20% and 60% or whatever. So we can sample within that, and we know that in any given year it could realistically be that. Right. And after you do that 10,000 times, that's where you get this figure like figure 5 that is a bell-shaped curve, and that's just telling you that line that you're seeing there is telling you how often did we see the population would be at stable or growing? So that's one or more.
And it's not going to be every year because, like, as we've talked before on this show, in general, turkey populations are very cyclical, and they're marked by a good year every now and then, and they mix in some really bad years too. It's up and down.
Yeah, and I think that's a good way for us to focus on it. And this was a little bit confusing to both of us, I think, up front. And we had to be told how this could work. But on an average year, where you have average hen survival and average reproduction, the turkey population is not increasing. What happens is, the reason it's on that cycle is you all of a sudden have the stars aligned for some reason, and then the reproduction is really high, and sometimes the survival and reproduction is high together.
Right.
And in those years, the population grows a lot, and then you kind of, you go through several years that are not so good.
Yeah.
In an average year or a poor year on average, they would decline.
Yeah, and I think one thing that we should stop right here and mention is what you just laid out emphasizes the importance of adult female survival, because you have to have those hens sticking around for those good years of reproduction.
That's exactly
and if
right.
they're not sticking around, you're back at square one again.
Yeah, and I think we're seeing that influence in this model where, on average, populations are declining, and when you have low hen survival, that's not good. When you have low annual hen survival, because they're not around when you have the big year.
Right.
That hen can't reproduce if she died last year.
Right.
So you want high hen survival because they have, a relatively long lifespan, and they're more likely to be there when you hit one of those good years when the stars align.
Exactly.
So that is kind of in a nutshell what we're talking about. So on average, about somewhere between 80 and 85% of the model runs under the historical hen survival, about 80 to 85% of the time.
When hen survival was higher.
Yeah, when hen survival was normal, but let's call that normal, what it used to be, about 85% of the time, or 80 to 85%, 1 in 5 years, or 4 out of 5 years, the population would actually decline.
Right.
And then every 5th year, on average,
yeah.
Again, we're talking in averages. There's outliers.
So it may be more often, or it may be even less often.
Yeah. So when we're in the 80th percentile, in other words, when we have that big reproductive year, which on average would have occurred 1 out of every 5, historically, the population would be stable or growing in that year. And that'd be enough potentially to stabilize a population in the long term. You'd still see that cycle.
Right.
But every 5 years, you'd get a big reproductive event, and hen survival is high enough to take advantage of that, and you end up with a thriving population.
Right.
What we saw, though, is with the observed decrease in hen survival, that went from one year out of every 5 years that we should expect a boom year to about 1 out of every 10 years.
Wow.
So you can see that's a big thing now.
Yeah.
Because now 1 out of 5 years is within the lifespan probably of most hens, but 1 out of 10 years is not.
Right.
So a lot of hens probably don't survive long enough to even hit the boom year.
Right.
And that to me is why this matters a lot. It's not like we didn't see that, populations just always grew in the past, but we were having boom years frequently enough that they were growing. In most places, at least. And now I think, this tells us that maybe we're in a situation where we don't have boom years quickly enough to overcome this hen survival problem.
And the other thing that was really interesting to me about this analysis is because we modeled those different scenarios of reproduction. So we broke out the same way we did with hen survival in the literature, what those ranges in nest success and poult survival would be, and we drew from that range.
Yeah.
But then we broke that range down further into what we would consider, maybe like the lower third, the middle third, and the upper third in terms of nest success in brood survival. So when you're under that high reproduction scenario, that high reproduction year, when you're under that current scenario of low hen survival, it is still inadequate, that high reproduction is, to increase that population.
Yeah.
So it doesn't matter in that scenario if you improve nest success or brood survival, the population is still decreasing. And what's alarming about that is that's where we've been putting so much effort and emphasis in our management and in our teaching and our research, right? And this is telling us that we should focus on something else, or maybe there are things that we can do that increase both at the same time too.
Yeah, I was going to say, unless the same thing we would do to increase nesting success also increases hen survival.
Yeah.
And it makes sense, since a lot of most hens die during nesting.
Yes.
Or brooding when they're anchored to a nest or a brood on the ground through the night, specifically. It makes sense that if we improve vegetation associated with that, and that increases the nest survival, it probably would the hen survival also.
Right.
And that's another important point, I think, for people to realize is, you're right, we might be doing that action for the wrong reason. But we may do the same thing if it was just for the right reason in this case. We're not sure, but we're working on it.
Right.
I would add on to that, one thing, the reproduction, at least in some cases, in some publications, has been declining, if anything. So that has happened. So we don't just have the hen survival problem, but we're also not getting those big years as frequently, most likely, either.
Well, that's an indicator that the two may be linked.
Well, and the other thing I would say that I think it probably likely is linked, although interestingly, there's no literature where that people have correlated those two. But I don't know if you remember, I did correlate them in this data set. This is not peer reviewed, but there was a correlation between nesting and survival across studies.
That's really interesting.
There was a positive correlation, but here's what that means to people. If you do things that increase nesting success and hen survival, let's pretend for a minute the same thing would increase both, the effect size that you have on the population's growth is enormous. That's actually what you want to happen, right? You want to increase the hen's survival during nesting and her nesting success. And those have this non-additive,
this multiplicative
effect, that have a huge impact on population trajectory. So if we can affect both of those with the same action, we get a far greater output from that in the population. That's what
that's where we need to be spending our time and resources.
Yeah. Which, hopefully they are correlated, and then we can implement things to improve that together, and that will have a major impact on population trajectory.
I know those are averages, but you would think on average it would have to be at 1 or above for that population to ever grow and not, or to at least not decline.
Well, that's the 75th percentile. High is 75th percentile. That's where I was trying to figure out what is the actual percentile we need to be in.
But on figure 4, if you look at high, it's not even, lambda's not even hitting 1 under high survival. With high reproduction.
Yeah, I know. The 75th percentile is still declining.
Okay. It's got to be in the 81st, is what you're saying?
So high means it's in the 75th percentile for both metrics, and it's still declining even if it's in that. It's almost stable. So that's what I was trying to...
That's what you were saying about the 80%. It's only 1 in 5 years where you get reproduction high enough.
Yeah.
Okay.
So the question that people are probably wondering is, why did hen survival decline?
Yeah.
We were working on that. I don't know, but we have some ideas.
And
we're not the only group working on this, so we'll see what shakes out and holds up to the rigor of science.
Yeah.
But I think this is fairly compelling evidence that we need to be looking at that.
Yeah.
So but at hen survival in particular.
Well, what's striking to me about these data is how similar those curves are across all the different areas, because that is the one problem that I feel like anytime you bring up the issue of wild turkey decline, not anytime, but many times, people always have a counterpoint to anything that almost any factor that you name as being responsible or primarily responsible or contributing to that decline. They'll provide you a counterpoint. Well, what about Iowa? Or just like nothing's changed there, or this hasn't, or that hasn't happened there, or whatever. Those types of comments that people make. But this is showing that this phenomenon with hen survival is across almost the entire range.
Yeah. And it's been consistent. There's not any outliers other than Wisconsin. I mean, it's very consistent. It spatially and temporally matches what we've observed for the most part, as far as we can tell. There's lots of potential things, but, in most cases, we are shooting virtually none of the hens, so probably not that. I know there's a bunch of predator folks out there who's like, well, of course it's predators. Well, predators eat hens, yes, but there's not any obvious changes in predation rate of hens based on the literature. Mm-hmm. Although we did note, we did go through the things that we think might be at play here in our discussion, so y'all can read that if you want to, but I'll kind of give you some ideas. I think the negative density dependent idea from Byrne is a reasonable one. We might be in a situation where hens are using more marginal areas now, and they're more vulnerable because of that. So it's a natural effect of having a high density, is that some of the hens are in poorer places to live,
right,
or in poorer condition or something that makes them more prone to dying. So that's perfectly reasonable. Food availability associated with habitat or insect declines, declining hard mast, those kinds of things could certainly play a role into this. Another thing that coincidentally happened to happen on about the same time frame is coyotes expanded into and got established in some of the states in the east. Mm-hmm. However, the same decline was observed in places where they were always there.
Yeah.
So we'll note that.
Yeah.
But I'm trying to be thorough here.
You haven't brought up disease yet.
Yeah. Well, we were going to get to that. That was the last one I was going to talk about because I think it might be the most in the black box.
I can't help it. I want to get there now.
Well, the other one that just coincidentally happened to explode on the landscape in the same time span is feeding.
Yeah.
I mean, it just exploded.
Yeah.
So we've talked a ton about declining habitat quality. So the reality is probably a combination of factors that are interacting that are contributing to this, and it might not be the same thing everywhere, but we were trying to lay out all the ideas that we could think of, and exposure to higher predation or toxins or something associated with feeding could certainly be that, or disease associated with that practice, or just emerging diseases, because we have some diseases that are new kids on the block in that time frame.
Yeah, but circling back to something you said a second ago, most of our hens are killed by predators on the nest, during the nesting season. That's by far when most of those adult hens are being lost.
That's super common across studies, is the hen loss happens during nesting or brooding, early brooding.
Yeah.
When she's tied to a nest or a brood on the ground through the night in particular.
So I think it's some combination of like you said, all those things probably are playing a role. But, the most important things, in my opinion, are going to be those vegetation conditions around where she's nesting, because that's obviously going to affect her survival. Right. And then whether or not the predator context has changed, which we have some evidence that it has. And also thinking about what are the factors that are contributing to that changing predator context, i.e. corn, like you just mentioned, or, decreasing use of prescribed fire or something like that draws them into the upland areas.
Let's paint a picture right here. I mean, we had turkey populations increasing. At the same time, we've got habitat amount decreasing, habitat quality in many ways, especially for nesting, decreasing, and you have more turkeys trying to nest, and then you add in the fact that the changes in that habitat quality are probably increasing quality for some of those predators, and we're subsidizing them.
Yeah.
I mean, that to me is a pretty plausible explanation that we're putting hens in a situation where they don't have much good to choose from, and there's more of them to choose among it, and we put them behind the 8 ball in terms of the other factors that would influence whether or not they get eaten during it.
And oh, by the way, let's sprinkle in a little bit of make them sick while all that stuff is affecting them. We got new diseases or increased prevalence of diseases.
Yeah. So, bottom line is we're not sure what is happening, but this was an important step to try to identify a potential hypothesis, which will spawn into a lot of work. And it already is.
Mm-hmm.
We have a couple of studies looking at how different factors related to vegetation and practices, other practices affect hen survival on the nest particularly. One of our colleagues reached out recently asking for hen survival data from a bunch of different turkey labs, trying to model this from contemporary data sets across many study areas. So we're trying to get answers.
Yeah.
And I hate to not have it now, but that's the reality of the situation. I think this is a pretty compelling analysis to suggest this is worthwhile for us to explore and try to figure out, is this the problem and why is it the problem if so, and what can we do about it?
Well, the exciting thing about this is that up until now we haven't even really known the what.
Yeah.
So how do you go about discovering the how and why if you don't even know the what? And now we have proven with data that this is the change in hen survival is sufficient. Not necessary. We don't know that it's necessary, but it is sufficient to explain some of these declines in abundance that we've seen. And now we have to start, exploring those mechanisms that could be driving it. And so,
right.
One of those we just touched on was the predator aspect and feeding of predators, and we've got research going on right now directly addressing that. So the good thing about this is it starts to give us some hypotheses to test.
Yeah.
And then we get at
it gives us some
how
direction.
and why. Yeah.
And for a while, ever since we got on this path, I have been really focused on trying to address different aspects of it because it is that important. We know that vital rate is that important. And if this is really what's happening, we need to figure out why, and then figure out, is there a management strategy to deal with it at scale?
Yeah. Yeah. Well, that's the other question, right? Too. It's like you go what, and then, how and why. And then you think about, well, then the next step is, well, what can we actually effectively do about it? And hopefully it's something that we can affect change in. Because sometimes in wildlife populations, it's something we have absolutely zero control over.
Yeah. So we've been holding this one a while, and I know it felt like I was rambling along a little bit for me with some of this, and I'm also trying to
it's very
explain
technical.
It in a way that makes sense to me and everybody else, and it's difficult to navigate. Maybe we'll have to get Anna on here to tell me where I was wrong. But
or
you got the gist of it.
Or you know what, they can just send us their questions about what doesn't make sense, and we can do a follow-up episode and try to make things more clear.
Yeah,
but I was really, really excited to share that information.
Yeah, me too, because we've been holding it a while, and also to me, like you said, it's it's a mighty strong coincidence if this isn't it.
Yeah. Well, how frustrating is it? Is both of us, I think, would consider ourselves as wildlife managers in addition to being researchers. And so we like to go out there and boots on the ground, make stuff happen. But dang, it's frustrating when you don't even know what it is you're trying to battle against.
Mm-hmm.
And I feel like now we have at least some insight into what it may be.
Yeah. We do at least know that most of the time hens die while they're nesting. So I would have to expect that if we improve concealment cover, we're probably going to positively influence her survival while influencing nesting success.
Mm-hmm.
So we can come up with some ideas of what we might do before we really figure this out. Like that's probably going to benefit it, and not decrease it. A lot of the things that we talk about with habitat management that are focused on nesting and brooding cover are probably also influencing her survival during those events.
Yeah.
So I think we do have that to
Plus,
lean on.
If we know we have to be in those top percentiles of reproduction to overcome this problem, we better be doing a dang good job of that.
You're dang right. Like when the time comes and the stars align and all the eggs are ready to hatch and the poults are going to make it, we better make sure we give them the opportunity to let them take advantage of it.
Mm-hmm.
Exactly right. And a dead hen's not going to raise any. So.
Is that where we're going to leave it?
I guess. So
that was
I'm
kind
curious
of a
to see
dark place to end.
Well, a live hen could have many.
Yes.
There we go. I just leaned up into the brightness of the sun that's in my eyes to tell you.
Like making sunlight into gobblers.
Yeah. So I hope everybody enjoyed that, and we were glad to take questions, everything, and link this work. I was very excited about this because I think it was a compelling hypothesis. So curious to see what folks think about it. Thanks everybody for listening. Appreciate you for listening too, Will.
Anytime, Marcus.
Wild Turkey Science is part of the Natural Resources University podcast network and is made possible by Turkeys for Tomorrow, a grassroots organization dedicated to the wild turkey. To learn more about TFT, check out turkeysfortomorrow.org.